Okay, so today we begin our unit on matrices. So the first section, 4-1, is operations with matrices. So we're going to learn how to add and subtract and then scalar multiply matrices. So that is the goal for today's lesson. So the rules, the first thing we want to talk about is what is a matrix and what does it do? It's a way to organize data. And so I'm going to just call this matrix, draw this simple matrix, which is a 2 by 2 matrix. And the first number is always a number of rows, so there's 2 rows, and the second number is a number of columns. In this case, I made one with 2 columns as well. Okay, each of the numbers inside are called an element. Okay, so these are 4 elements inside the 2 element by 2 element, 2 row by 2 column matrix. Okay, so it's always rows by columns when you list the dimensions of the matrix. So if I want to call this is matrix A, and it's a 2 by 2. So they name them and then tell you the dimensions. Okay, to add or subtract, I'm going to kind of do a generic format that works for either. Let's say we're going to take matrix A, B, C, D, and we're going to add or subtract, it doesn't matter which way, to matrix E, F, G, and H. Okay, then the answer, you take each element and find the corresponding element in the same position. So A is in the same position as E in this matrix, and then you either add or subtract those elements from each other and put them in the same position. So I'm putting the subtraction in parentheses underneath. So again, if you're adding, you would add them A plus E. If you're subtracting, A minus E. And then you're going to do the same thing in the next position. So we have B plus F, or it could be B minus F. And then we have C plus G, or again minus. And then we have D plus H, or again it works for minus. So when we're adding or subtracting matrices, again, you find the same elements in the same position and you add or subtract them. It has to have the same dimensions. You cannot add a 2 by 2 and a 2 by 3. It has to be the same dimensions in order to add or subtract. To scalar multiply, okay, so if you're scalar multiplying matrices, this is what, when you take a number on the outside and you're going to multiply everything inside by it. So I'm going to call this matrix E, F, G, H again. I'm multiplying the matrix by A. So when you scalar multiply, you just take each element and multiply it by A. And that gives you your new matrix. So adding and subtracting, add the elements that are in the corresponding location or subtract them. To multiply, if there's a number on the outside, you distribute it basically to every position. Okay, and that's how you do matrices. So let's go to the I do. And for this one, we're adding, and it is a 3 by 2 matrices, and this is a 3 by 2. So again, the dimensions match, so we can add them, and our final answer will be a 3 by 2. So we take the 2 and add it to the -6, and we get -4. -1 plus 9 is 8. 3 plus 7 is 10. 7 plus -11 is -4. 14 plus -8 is 6. And -9 plus 17 is 8. Okay, and there's another one here. This one is subtraction. So again, this is a 3 by 1 matrix. This is a 3 by 1, so we can subtract them. 4 minus a -6, we're minusing a -67 becomes 71. -71 minus 45 is -116. And 18 minus a -24 is 42. So you're going to do the same thing on these. You're going to add or subtract them. It says if the matrix does not exist, write impossible. So if the dimensions are not the same, you have to write impossible. And you're going to do that for these 3 through 6. Then we get down to number 7. And again, this is an I do. The reason why is now we're getting to multiplication. So we can look at what happens with multiplication. So there's a multiplication in front. We're going to, again, distribute that to every element inside the matrix. So we're going to get negative 3 times negative 1 is 3. Negative 3 times 17 is negative 51. Negative 3 times 0 is 0. Negative 3 times negative 11 is positive 33. And then we have a plus, and we're going to distribute the 4. 4 times negative 3 is negative 12. 4 times 16 is 64. 4 times negative 21 is negative 84. And 4 times 12 is 48. And then we're going to add just like we did up above. So 3 plus negative 12 is negative 9. 0 plus 64 is 64. Negative 51 and negative 84 is negative 135. And 33 plus 48 is 81. So now we're going to look at number 8. For this one, again, we're going to distribute that 7. 7 times 2 is 14. 7 times negative 1 is negative 7. 7 times 8 is 56. 7 times 4 is 28. 7 times 7 is 49. 7 times 9 is 63. And then when we get to this one, you have two choices. You can keep this as a minus and distribute the 2 and then subtract everything. Or you can think of this as a negative 2. And I like to do it that way, but when you do that, if you're distributing the negative 2, make sure you put a big old plus sign. This is going to be addition. I distribute the negative sign, so then I get through the negative and it makes it addition. So negative 2 times negative 1 is 2. Negative 2 times 4 is negative 8. Negative 2 times negative 3 is 6. Negative 2 times 7 is negative 14. Negative 2 times 2 is negative 4. Negative 2 times negative 6 is 12. And now we're going to add these together. So if you distribute the 2 by itself, then you still subtract. But if you put it together, which I find easier, then you add. So now we're going to do 14 plus 2 is 16. Negative 7 plus negative 8 is negative 15. 56 plus 6 is 62. 28 plus negative 14 is 14. 49 plus negative 4 is 45. 63 plus 12 is 75. I apologize if you checked my work and I made any mistakes. I'm doing this kind of nice and fast. So that is number 8, and that's the I do. So if you kind of move forward, you're going to do numbers 9 through 16, following the same idea. Distribute any numbers on the outside and then add or subtract your matrices. And then we get down to this section, and this is the same idea, except for now they're giving you your matrices here, and they want you to plug them into the formula or into the expression. So this first one, A minus B, so I'm going to write down the A matrix, which is 4, negative 1, 0, negative 3, 6, 2, and then I put the minus, and then I'm going to write down the B matrix, which is negative 2, 4, 5, 1, 0, 9. And then it says to subtract them, so I'm going to subtract. 4 minus negative 2 is 6. Negative 1 minus 4 is negative 5. 0 minus 5 is negative 5. Negative 3 minus 1 is negative 4. 6 minus 0 is 6. And 2 minus 9 is negative 7. For this one, again, we're going to substitute in the matrices. So we have a negative 2. And then we're going to substitute in B, which is negative 2, 4, 5, 1, 0, 9. And then we have minus 3, and then we're going to substitute in C, which is 10, negative 8, 6, negative 6, negative 4, 20. And then we're going to distribute. So on this one, I'm going to distribute the negative 2, and we get negative 2 times negative 2 is 4. Negative 2 times 4 is negative 8. Negative 2 times 10 is negative, or 5 is negative 10. Negative 2 times 1 is negative 2. Negative 2 times 0 is 0. Negative 2 times 18 is negative 18. Once again, I'm going to distribute this negative 3 and turn this to a plus. I distribute the negative. Negative 3 times 10 is negative 30. Negative 3 times negative 8 is 24. Negative 3 times 6 is negative 18. Negative 3 times negative 6 is positive 18. Negative 3 times negative 4 is 12. Negative 3 times 20 is negative 60. And then lastly, I'm going to add my matrices together. 4 plus negative 30 is negative 26. Negative 8 plus 24 is, sorry, I lost track of where I am, is 16. Negative 10, negative 18 is negative 28. Negative 2 and 18 is 16. 0 and 12 is 12. And negative 18 and negative 60 is negative 78. Final answer. So again, that you're going to use these matrices and substitute them into the expression. So on the next page, there are 4 more. Again, you're using these matrices that are here on this page to do the next 4. And then the last one is a word problem, and they want you to write the matrices. The matrices they're looking for is basically boxing these off. So there are your 2 matrices, so write those out here, and then you're going to find the sum of the 2 matrices. So that is our lesson, our first lesson on Introduction to Matrices. I will see you tomorrow.